In this lesson, we're going to look at circles as part of our circles and ellipses module. And a circle, by definition, is the set of all points lying in a plane that are equidistant or equal distances from a fixed point to the center. The distance from the center to any point on the circle is called the radius. So just definitions there. The standard form for the equation of a circle that has centered at hk and has a radius of r is x minus h squared plus y minus k squared equals r squared. And if the circle's centered at the origin, then h and k would be 0, so we get x squared plus y squared equals r squared, or the radius squared. Okay, so let's look at a question. Write the equation of a circle with radius equals 7 and centered at negative 3, 2, then sketch it and state the domain and the range. So if we, and then answer the question, is this a function? So we'll just use the standard form. We'll say x minus, there's our h is negative 3, so negative 3 squared plus y minus 2 squared equals 7 squared, our radius squared, and we'll just simplify that to x plus 3 squared plus y minus 2 squared equals 49. So there's the standard form for the equation of that circle. So now we can sketch it as well, because we know that the center is at negative 3 and 2. So we can plot that point. And since the radius is 7, in order to sketch it, we can go 7 units from that center. So 1, 2, 3, 4, 5, 6, 7 up, 7 down. And I need to scroll down just a scooch for that to work. 2, 4, 6, 7, and I can go across 7 in both directions. And then I can try sketching it. Now I've lost my top dot, so it's very easy to make that look like a diamond. So I find that to make it as round as possible, I have to really make sure I'm arcing at each of those points instead of turning them into points. And it's a little easier on pencil. It looks a little bit weird. So now let's state what the domain and the range are for this. We can read that from the graph. We can see that the domain goes from negative 10 to positive 4 and includes those two. And that the range goes from negative 5 to 9. Now, without the graph, we'd actually be able to figure out the domain and range as well, because we know that the center, for instance, if we look at just the domain, we know that the x value is negative 3, and we're going 7 to the left of that and 7 to the right of that. So we can easily find the endpoints for our domain and likewise for our range without having to sketch the graph first. If you wanted to use a graphing calculator, we'd have to rearrange the equation first into y equals form, because the calculator wants you to fill in the y equal stuff. So let's take a look at that equation. If we rearrange it so that we just have the y part to the left, we'll have 49 minus x plus 3 squared. And so we'll take the square root of both sides. So we'll get y minus 2 equals, remember when we take the square root of something, we have to take care of the positive and the negative root. So we have plus or minus root 49 minus x plus 3 squared. So now to get the y completely by itself, we've got plus or minus the square root of 49 minus x plus 3 squared plus 2. That plus 2 does not fall under the brackets there. So really on the calculator, you would have to enter two equations because there's no symbol for entering this plus or minus piece. We would have to, beside y1, we could enter the square root of 49 minus x plus 3 squared plus 2. Yes. And beside y2, we'd have to write negative the root of 49 minus x plus 3 squared plus 2. And watch your bracket placement, and we can practice these in class, but it'd be a good idea to practice that on your own first too, so that you can see one of these will sketch the top half of the circle, and one of them will sketch the bottom half of the circle. And depending on the calculator, this middle area that's almost vertical, it will have a hard time sketching that part. Okay, let's move forward now, but being able to sketch it with the graphing calculator is a nice way of testing your work. So here we have the equation of a circle. Let's state what its center is and what its radius is and its domain and range. So we're not going to graph this one, okay? So there's our h, there's our k, and we need to switch the sign because this would be x minus negative 5. So our center will be negative 5, positive 2. The radius will be 4 because it's the square root of 16. And our domain and range will be, if you think about if the center is at negative 5 and the radius is 4, I'm going 4 lower than that and 4 higher than that for the endpoints of my domain. So we're going to go from negative 9 to negative 1. And our range, our center is at 2, and we're going 4 up and 4 down from that, so we're going from negative 2 to positive 6. And to answer that question from earlier about whether this is a function or not, a circle is not a function. It does not pass the vertical line test. And if you think also about for each x value, there can possibly be more than one y value because if you look at the earlier example where x was negative 3, there were two y values. There was one below it and one above it, the center of the circle. All right, now let's look at the second form for the equation, okay? The second form is called the general form. So we're going to start with the standard form of example 2 that we had. And what we do is we get rid of the brackets and we collect like terms, okay? So if we start with this example, when we take x plus 5 squared, we're going to get x squared plus 10x plus 25. Very familiar quadratic expansion there, plus, and then we'll expand the y binomial there with that y squared minus 4y plus 4 equals 16. And to get into general form, everything has to be left of the equal sign and our like terms collected. So we're going to subtract 16 from both sides, so we have a 0 on the right, and we'll get x squared plus y squared plus 10x minus 4y, and I have the 25 plus 4 minus the 16, so plus 13 equals 0. And that's the general form for the equation of a circle. The general form takes this form, x squared plus y squared plus dx plus ey plus f equals 0. D, e, and f are real numbers. So that means they can be positive or negative. They don't necessarily have to be whole numbers, okay? The general form is nice, but it's harder to see what the radius and center are. So standard form is the preferred method for looking at the equation, but so if you're given general form, like in example 3 here, we need to be able to do the conversion into standard form so that we can quickly sketch that, because this is very challenging to sketch this. So to put it to convert this to standard form, take the two x terms. So we're going to get x squared plus 12x. And then take the two y terms, leave a bit of space there. So we've got plus y squared minus 6y equals, and take any constant, remove it from the left side of the equal sign. Okay, and I should have had a little bit of space there after the 6y, so let me just fix that, equals 4. And what we're going to do now is complete the square, and we did this when we were working with quadratics, changing from standard form to transformational form, and we're going to do the same thing here. Think about what you'd need to add here in order to turn this into a perfect square trinomial. And it's the same way that we did it with quadratics. We take half of the 12 and square it. So in this case, it's going to be 36. And we take half of the negative 6 and square it. So that'd be negative 3 squared, which is 9. And we add that. But to keep things equal, since we're adding 36 and 9 on the left side, let's make sure we add that on the right side too, so that'll be plus 45. So the equation has stayed equal now. So now we can factor this part and this part into perfect squares. So we get x plus 6 squared plus y minus 3 squared equals 49. And this is now in standard form, so that we can see that the center of this circle is negative 6 and positive 3, that the radius is equal to 7. So let's sketch that. So I've got a center at negative 6 and positive 3, and my radius is 7, so I can go 7 in all 4 directions. And there's 3, 1, 2, 3, 4. And I can sketch in my circle. And if I pretend that that dot should be further out, oh, it's terrible. It's much easier on paper and on a whiteboard with a whiteboard marker to make that look a little more round. And let's state what our domain and range are here. Okay, so domain, if my center's at negative 6 and I'm going 7 to the left, I'll be at negative 13, and 7 to the right will be 1. And for range, if my center is at 3 and I'm going 7 down from that, I'm at negative 4, and 7 up from that will be 10. So there's the domain and range of that function. And that is almost all you need to know about circles.